Alright, so welcome to the last little lesson of this unit for right before the Christmas break. So we're going to start with the second derivative test. So there's part 1. There's part 2. So essentially what this is saying is, once I take the derivative of a function, find its zeros, take its derivative again, plug in that 0, if that is greater than 0, then it has a minimum. If it's less than 0, then it has a maximum. And then if it fails, it could have potentially nothing, and I would have to go back and use the first derivative test. So, that being said, let's chug on. So first steps first, I need to go ahead and take the first derivative of this function. So again, I'm just gonna call it f of x. So it's gonna give me negative 15x to the fourth plus 15x squared. Step number 2, take that derivative, set it equal to 0. What are you scratching at? Had to make sure she wasn't going up to the couch again. I'm going to take out a negative 15x squared. That leaves me with x squared minus 1. Which continues to factor into x minus 1 and x plus 1. So my zeros are 0, 1, and negative 1. So what I'm going to do is I'm going to now take the second derivative. Which will give me negative 60x cubed plus 30x. So these are my key guys here, my 0, my 1, and my negative 1. So what I'm going to do with those is I'm going to plug those numbers into my original function to find the original points. So when I plug in 0, my output is 0. When I plug in 1, I get 2. And when I plug in negative 1, I get negative 2. Now what I'm going to do is I'm going to use these x values. I'm going to plug these x values into the second derivative. So when I plug in 0, I get 0. So nothing happens at that point. That's just a specific point. When I plug in 1, I get negative 30. So this is a relative maximum, or just a maximum. When I plug in negative 1, I get positive 30. So this is a relative minimum, or just a minimum. Because we didn't talk about when we did the first derivative test, relative maximum. We just said you could call them that if you wanted to. It doesn't matter, same idea. So you're probably thinking, why is this second derivative, if it's positive, a minimum? excuse me. Well, if the first derivative, so say I have this function, this graph. If the first derivative gives me the zeros, the second derivatives tell me ow. Let me try again. So the first derivatives tell me the zeros, and they tell me if something's increasing or if something's decreasing. The second derivatives give me concave up or concave down. Typically, if I plugged in a number and got a positive output, it means it's concave up. So if it's concave up, wouldn't your assumption be that it's a minimum? Likewise, if we get out a negative number, that means it's down. And if it's down, concave down, excuse me, wouldn't that make you believe that it is a maximum? So while these two seem completely out of nowhere, out of left field, why it's the opposite, it all goes back to concave up and concave down. So if you're concave up, you're going to be a minimum. If you're concave down, you're going to be a maximum. All right, let's try this next bad boy. So we have f prime of x is 8x cubed minus 24x squared. Take that guy and set it equal to 0. So x is 0 and x is 3. Step number 2. Go ahead and take the second derivative now. Okay, so when I plug in 0, I get 4. When I plug in 3, I get a whopping negative 50. So when I plug in this point of 0 into my second derivative, I get 0, which is nothing, which means this guy is absolutely nothing to me. It's just a point. When I plug in 3, however, I get a positive number, which means that this guy is a minimum. Alright, same kind of idea. First start first with my first derivative. Go ahead and find my zeros. So x is negative 3/2. Now, when I go to try and take the second derivative here, that's just going to be a constant. Am I going to be able to plug anything in here? Nope. So because I can't plug anything into this, I'm going to have to use the first derivative test. So I've got my points, so from negative infinity to x to negative 3 halves to negative 3 halves plus x is less than infinity. So when I go ahead and plug those in, I'm going to pick now negative 3 halves is negative 1.5, so I plugged in negative 2. And I'm going to plug in that negative 2 in my derivative. So I get negative 8 plus 6, which is negative 2, which is a negative number, so I'm decreasing. I'm going to pick another number over here that is bigger than this. I'm going to pick 0 because 0 is always an option. When I plug in 0, I get 6, which is a positive number, so we are increasing. So if I am decreasing, so here's my point, if I'm decreasing then increasing, I'm going to have a minimum, or if you remember your chart, you should know it's a minimum. And it's going to be minimum at negative 3 halves, negative 41 halves. That's my answer. Alright guys, see you later.